Bismillahirrahmanirrahim. Dear students, our today's lecture is about metallurgy of copper. My name is Dr. Muhammad Asif Iqbal. So let's we start our today's lecture. At first, the ore is crushed into smaller pieces so we can easily deal with the ore particles. So it means we can increase the surface area. At the first stage, the ore particles are mixed with oil, and here we introduce water, and here we introduce the compressed air. What will happen when we start agitating this ore with water and oil particles? All the unwanted particles will settle down here, and the ore particles, they are surrounded by the oil particles, so they become lighter in nature, and they comes at the surface of the water, so we can easily remove the unwanted particles from the ore. So in this process, we can concentrate the ore particles. What is the purpose of the oil? When the oil particles they surrounds the ore particles, they become lighter in nature, and they comes at the surface of the tank. So by this way, we can remove the unwanted particles at the bottom of the tank. So by this way, we can remove all the unwanted particles from the ore. What is the purpose of this oil? When this oil surrounds the ore particles, they become lighter in nature, and they comes at the surface of the tank. So by this way, we can remove all the unwanted particles at the bottom of the tank. The next stage is the extraction of the copper from concentrated ore. In this process, the copper pyrite is strongly heated in the presence of air. Here you can see the sulfur in the copper pyrite combined with the oxygen to form the sulfur dioxide, and we obtained copper sulfide. We have two states of copper. One is called cuprous and one is called cupric. And here we can see this is the lower oxidation state of copper. So that's why the formula of the copper is Cu2S, and we have here the lower oxidation state of iron, Fe(S). The next state is called smelting. Ferrous sulfide oxidizes to form ferrous oxide, which reacts with the sand to form iron silicate. So in this process, you can see here in the previous process, we have two things: copper cuprous sulfide and ferrous sulfide. So in this step number 2, we can remove this unwanted particles of iron ferrous sulfide from the ore. Here you can see at first ferrous sulfide combines with oxygen to form ferrous oxide. And in the next stage, it combines with the silica particles to form iron silicate. So we have removed this ferrous sulfide in the form of this iron silicate in the form of slag. Now, our main concern is about this thing, cuprous sulfide. From this cuprous sulfide, we want to get pure copper. Cuprous sulfide oxidizes to form cuprous oxide, which reacts with the unreacted ferrous sulfide to form ferrous oxide. You see here the lower oxidation state like this to form ferrous oxide and cuprous sulfide. Cuprous sulfide and ferrous sulfide form a mixture like this one. So we can, by this way, which is carbonate. So it means by this way, we will remove iron sulfide from the ore particles. Here, this you can see here. I have shown it with the blue color, so you can easily understand here. Here I have shown it with the green color, and here we have removed here. So in this step, you can see here, it forms cuprous oxide. Of the next, here you can see also the remaining one will combine with this remaining one. So this one, again, it combines with oxygen to form like this one. So by this way, the process continues. Extraction of copper from the concentrated ore. This is called vaporization. You will see here the remaining iron sulfide means the ferrous sulfide, the remaining particles we will remove here to make it more concentrated at this stage. So before moving to the next stage of the refining, here we will remove all the unwanted ferrous sulfide from the ore. You will see here the same chemical equation. This ferrous sulfide combined with the oxygen to form ferrous oxide, and again it combines with the SiO2 to form FeSiO3. So it floats at the top, so we can remove it. Here you can see the same chemical equation which I have shown in my previous slide. This cuprous sulfide combined with oxygen to form cuprous oxide, and sulfur dioxide is removed here at the gaseous chamber. So by this way we can remove. And here this cuprous oxide combines with the cuprous sulfide. So here we get copper. Now this copper is free from sulfur and from the iron particle as well. For using this copper as such for domestic purpose or industrial purpose is not good. So we have to refine this copper so it becomes as a good conductor of electricity. So we have to remove the remaining unwanted particles. So the next stage is called the refining. Refining of copper. Here you can see we have put the impure copper, and here is the pure copper. Electrolyte we used here is sulfuric acid and copper sulfate. So what happened at anode? Anode, it starts from a vowel. For better understanding what reaction will happen, A is a vowel, so here always oxidation will take place. Oxidation, what do you mean by oxidation? The removal of electron. And if we see here at cathode, here it starts with the consonant C. So here reduction, it starts with the consonant. So here always reduction will take place. Reduction means the gain of electron. So by this way, from this impure copper, we will obtain a pure copper. And here we get the anode matte. Anode has been eaten away. What does it mean? So by this way, this process, we can get the pure copper. Here, for a revision of our previous steps, I have shown here a flow sheet diagram for the extraction of copper. At the first stage, so right now I will make a quick revision of our today's lecture. At stage number 1, we have crushed the ore to remove the impurities. And here we use the fourth flotation process. In the fourth flotation process, we transfer the crushed ore into a big tank and we mix it with oil. Then we introduce water. Then we have introduced the compressed air and we have strong agitation. All the ore particles which were surrounded by the oil particles, they become lighter in nature, so they comes at the top of the surface. So easily we can remove the ore particles. Here at this stage we have concentrated this ore, and here the roasting, simply we have heated it with oxygen. So we have removed some amount of this sulfur in the form of sulfur dioxide, and the rest is converted into cuprous sulfide and ferrous sulfide. And here also we have not to removal of impurities in the form of slag. The next stage is smelting. Here also same reaction takes place, so we will remove the remaining content of sulfur. And here we obtained the copper. This copper is called blister copper because here the concentration of copper is not high for using for the industrial or domestic purpose. So by the electrolytic refining method, we have refined it to 99.9%. So this is called pure copper. Now we have, dear students, a very short quiz of our today's lecture. The first step in extraction of copper from the CuFeS2 is, you have 4 choices. Please choose the right one. The right one is roasting in oxygen. The next question is, roasted copper pyrites on smelting with sand produces. You have 4 choices. The right answer is choice number 1. Our next question is, the composition of copper mate is, you have these 4 choices. Please choose the right one. The right answer is choice number 1. The next question is, which of the following alloy of copper has, you have 4 choices, like 1, 2, 3. Choose the right one. Yes, the right answer is gunmetal. What is blister copper? The answer is yes. So this is all about, dear students, our today's lecture. See you tomorrow with a new lecture. Thanks a lot. Allah Hafiz.